Okay, 7.6, solving quadratic trigonometric equations. Example number 1. For each equation, use a trig identity to create a quadratic equation. Then solve for x in the interval from negative pi to pi using two decimal places. So you're given two equations here where they're quadratics. Now, very important to note, you will always try to factor first if you can. And if you can't factor, you'll be expected to use the quadratic formula. So those of you with a special funky duty calculator will have to understand that when you're doing this, you're going to have to make sure that you show me at least a couple of steps of the quadratic formula. So looking at this, 2 secant squared plus tan x minus 3 equals 0. So we're going to look at this first equation on the next page. Here we go. Now, don't forget that this is for within this domain. So x has these properties. Okay, so some of you are wondering, what am I going to do here? Looking at secant squared has a special property. And I'm going to show you where that comes from the Pythagorean identity. So given the Pythagorean identity, we're good right here. Now, I want to create secant squared x. What is secant squared x? Well, if you remember the reciprocal identity says that secant squared x is 1 over cos squared x. So what I want to do is create this 1 and make it 1 over cos squared x. Well, whatever I do to one side, I have to do to the other. That means I'm going to divide each of these by cos squared x. How does that help us? Well, this will equal tan squared x because of the quotient identity. This will equal 1. And this will equal secant squared x because of the reciprocal identity. Well, what do we have here is from the Pythagorean identity, we discovered that secant squared is actually equal to tan squared x plus 1. So I can replace secant squared in terms of tan. So we have 2 times tan squared x plus 1 plus tan x minus 3 equals 0. Expand it, collect like terms, and this is the full solution. So let's go a little bit backwards so we can see where this is going. So we have 2 tan squared x plus tan x minus 1 equals 0. What do we do with this is that we will factor this. That means that we're going to try and find factors of this. And we find out that 2 tan x minus 1 and tan x plus 1 is going to equal 0. So, and when I expand this, I will get these values. So, now we have to solve. So tan x is equal to 1/2 and tan x is equal to negative 1. What that will give us now, folks, is we can solve for x. So we take the tan inverse. Tan is positive in which quadrants? Well, hopefully you're thinking in 1 and 3. Tan is negative in quadrants 2 and 4. So, in this one, for 1 over 2, we need to find the related acute angle. Once I know this acute angle, I can determine this acute angle. And we get 26.5651 degrees converted to radians and negative 153.4349 degrees also converted to radians. How come it's negative 153? Don't forget, folks, that we still are working with this domain. So the domain has changed. So we want to go from negative pi to pi. That means when it falls in quadrants 3 or 4, we want the negative angle representation. If it falls in quadrants 1 and 2, we want the positive angle rotation. So, based on this, we have 26.5651 degrees for this one, and we convert it to radians. And for this one under here, we take negative 180 and add 26.5651 degrees to give us negative 153.4349 degrees converted to radians. So you just go ahead and convert those to radians. The other angle is tan x is equal to negative 1. The case of that is in the second and the fourth quadrant. This is a special angle, which is going to be pi over 4. So x is equal to negative pi over 4 in the fourth quadrant and 3 pi over 4 in the second quadrant. So these are our values, not in any specific order, of all of these 4 values that we have here. So these are the 4 calculated radian values. If you list them in order, you list them from the lowest number to the highest number. All right, let's look at example number 2. So part B. This was the other part. So we are trying to find the value of this. Okay, find the value of x within this domain. So looking at this, we have the biggest problem is this cos 2x. Using the DAF rule, we have cos squared x minus sine squared x. And I know you know that. Okay, so we have the full solution there, folks. Let's go back a bit. Okay, I use the DAF rule here to get cos squared x minus sine squared x. The problem is we want the expression in terms of cos squared x. In cos x, because this is already in cos x. So we want to express this in terms of cos x, or at least cos squared x. So what I can do is take the sine squared x, convert that using the pi, and pi says it's 1 minus cos squared x, and then you expand this out to get 2 cos squared x minus 1. So expand that out, you get 20 cos squared x minus 8 cos x minus 9 is equal to 0. Where did that come from? Well, when I expanded this minus 10, I add 1, you get minus 9. Here we have minus cos x. So we have 20 cos squared x minus 8 cos x minus 9 is equal to 0. What we have to do now is factor it. What two numbers multiply to give us negative 180 and add to give us negative 8. And that will be the following. So, solving for cos x, we have 9 over 10 and negative 1/2. Those are our 2 cos x values. That's because we're taking this bracket, setting it equal to 0 to get this value, and taking this bracket, setting it equal to 0 to get this value. You have cos x is equal to 9 over 10. Take the inverse, you get 24.8419 degrees converted to radians. Now, why plus or minus, you might be asking? Well, cos is positive in the first and fourth quadrant. So, again, because it's from negative pi to pi, if it's in the first or second quadrant, we want the positive angle, and if it's in the third or fourth quadrant, we want the negative angle. So what we're going up is the same we're going to be going down. So therefore, it's going to be plus or minus of these degrees converted to radians. The same goes for this value. This is going to be, a cosine is negative in the second and third quadrant, so I want the positive angle rotation and the negative angle rotation. Fortunately for us, this is a special angle, so we find out that the value of this will be pi over 3 as the related acute angle, which means 2 pi over 3 plus or minus to give us the value from standard position of the positive and negative angle. What we do then is convert this to radians. We can use the pi 3.14159 that we have in our calculators, get those values, and these are our final values for this question. All right, so reminder again, if you're unable to factor, you need to really consider using the quadratic formula. Hope this helps, guys. Good night. Take care.